can't pass gas through gas. Okay?
Yeah.
Sorry.
I'm sorry.
Before I trigger a cascade
of
flatulence jokes from Chuck. Okay. That we can't pass gas through gas. Right. Gas clouds cannot move through other gas clouds without consequence. It's like two hot marshmallows touching each other. They stick.
Right.
You ever done that? Two hot marshmallows?
Absolutely.
It's like contact cement.
Yeah.
So everything else passes through each other. The gas sticks together, and that energy feeds the formation of new stars. This is StarTalk, Cosmic Queries Edition. Neil deGrasse Tyson, your personal astrophysicist, with Chuck Nice. Chuck, baby, my co-host.
Hey, Neil, what's happening?
Yeah. And on your resume now, it starts saying Chuck Nice actor.
Yes, I mean,
in addition to comedian. What's up with that?
Well, I just figured, what the hell? Put it on my resume.
Did you want to say you were acting like a comedian?
Right. Yeah, that's what I might as well. I'm acting like a comedian. So let me just put that on the resume.
Put that in there.
Right,
Why not?
Exactly. You know what I mean?
So today's topic is a fascinating one, and it's so ubiquitous. It is so ubiquitous that, in fact, in the repertoire of public talks I give, one of them is entirely on this subject.
Okay.
And so I will visit a town, go to a theater, and 3,000 people will come and listen to me talk for 2 hours on this subject.
All right.
And it's called Cosmic Collisions.
Oh. Have you been injured in an accident?
Minus the attorneys. Yeah, most cosmic collisions, you're not injured, you are vaporized, or you die in some way.
Wow.
Yeah. So
No need
it's just
for a lawyer
things
then.
things that go bump in the night and in the day. So much that drives this universe is the result of things slamming into other things that it's just astonishing. Ways you might not have even thought about it. To give you a simple one,
Okay.
For example, you've heard of aurora,
Right.
Aurora borealis.
Yeah, the
and
northern lights.
You know what the southern lights are called?
No.
Aurora australis.
Oh, okay.
Didn't know that. There you go.
Crikey.
Yeah, it's your northern hemisphere bias for you to only think of northern lights.
This is true.
And not think of southern lights, right? So these are collisions between charged particles from the sun,
Okay.
in what we call the solar wind,
Yeah.
and our atmosphere, our upper atmosphere. These particles slam into atmospheric molecules, and it kicks them up to higher energy levels. And generally, atoms and molecules don't like staying at higher energy level if they can help it.
Right.
And so then they de-excite. And to de-excite, in many cases,
They get married.
in the cases,
My life is way too exciting. I need to calm this down.
Stop. So they'll de-excite, and in many of the cases, the de-excitation gives off visible light. And
cool.
the visible light is oxygen, it's nitrogen, it's sometimes it's sodium, other sort of chemical elements in our atmosphere. And that's what gives you the different colors.
Yeah, like
because,
fireworks.
And because the solar wind comes in sort of
Blowing
waves,
in
if I call it that, it blows in
from across the solar system.
So the aurora can change shape like instantly, right? It's an active, dynamic phenomenon. And so that's just one example of cosmic collisions.
Wow.
And so I'm leading off with that. I don't know if anyone's going to ask that, but apparently you got like a whole boatload of questions on this very subject. So let's see what you got.
You're absolutely right. It is a boat. Look at this. Every time I do this, and I still have like,
you're scrolling
I'm
the screen.
scrolling, yeah. Look at that.
Okay.
Look at that. Dude, it's unbelievable the number of questions we have here.
And because I give an entire talk on this, I am the local expertise on the topic.
That's
But
very cool.
normally, if it's a new topic, we bring in somebody who help us out on the cosmic
No need
queries.
for this one.
No, I'm good for this. Yeah.
Cool. Very cool.
And if I don't know, I'll say I don't know.
All right. And
But you never believe me.
I was going to say, okay. I mean, that's just not going to happen.
All right.
Actually, that's not true. There are times when you're like, okay, well, we don't know, but that's not going to stop you from talking to the subject in some way.
That's true, because we might know something. Plus, there are two kinds of I don't knows.
Right.
There's Neil deGrasse Tyson, don't know because I haven't learned it. And we don't know as is it is unknown to all humans on Earth. And part of what it is when you get your PhD in a subject is you learn thoroughly what we know and what we don't know, so that you know where the frontier is so you can go there and advance human understanding of the universe or whatever is the subject of your expertise.
But irrespective of the question, the answer will never be from either you nor any of your colleagues who hold that PhD. The answer will never be,
No, as an educator, I want you to leave still having learned something.
Right.
All right. So, but all right, look, we can test it. Yeah, I'm more literate than that. Yeah. Okay.
By the way, how cool would that be? Or, you know what else would be cool?
What?
When you give an answer and at the end of it you go, "Doy."
No.
I know.
All right,
here we go. This is Dade Bloomfield, and he says, "Hey."
Do we know where they're from? I like when they tell us where they're from, no?
Dade does not.
Okay, we got to solicit that next time. Okay, so go on.
So Dade says, "Hey, Dr. Tyson, Lord Nice, I'm Dade from Milwaukee." Sorry, there it is, Neil.
He's got it.
He put it inside the body of the question.
Okay.
How likely is it that if
that just means you didn't read the questions in advance? That's what that means.
I got time to read these questions. You know how long some of these questions are?
Okay. Dave, who secretly 2 sentences later is from Milwaukee.
There you go.
Okay.
Dade, as in Dade County.
Dade.
Okay. That's so funny because I'm so busted. He says, how likely is it that if an asteroid were to hit the Earth, that we would actually notice it in time enough to react? If we noticed it today, how long do you think it would take us to come up with an executable plan? And
I assume he means that if we know that tomorrow an asteroid is going to hit, what can we do in the next 24 hours?
Right.
Okay. So, of course, it depends on the size of the asteroid, right? So 65 million years ago, when an asteroid the size of Mount Everest struck the Yucatan Peninsula, what is today the Yucatan Peninsula, left a 100-mile diameter crater on that order of size. It doesn't, you just kiss your ass goodbye. 70% of the world's species went extinct, okay, including all the big-toothed dinosaurs. So there's certain size asteroids where you just sit on the beach and just watch it happen, and because there's really nothing we know how to do about it, all right? So that's just that. So it's not that in principle nothing can be done. Right now, we have people fighting over whether Earth is flat or whether they should take a vaccine, and you think we're going to coordinate in order to deflect an asteroid? I don't have that much confidence in civilization, sadly. So, but if it's smaller, let's say something that might take out a city.
Oh, okay.
Right?
That's, so manageable.
That's totally manageable. Right. Yeah, so what you do is you find out where it's going to hit. Usually there's uncertainty in the calculations of where it's going to hit. So we have what's called an error circle. But if it's something coming in at an angle, it becomes an error ellipse, an uncertainty ellipse.
Right.
So usually, in other words, you know better where it's going to land left to right than you will front to back because it's headed in that direction.
Right.
All right. So the error ellipse is this elongated circle in the direction of the path of the asteroid itself. So you find out what that is and then evacuate it. Okay, that's not all that hard. I mean, think about what happens. I live in Manhattan, and think about it. Every 24-hour period, millions of people enter and exit that island.
Very poorly.
In their workday, okay, through a system of bridges and tunnels and boats even. So that's New York. Millions move, okay? So it seems to me if we have some idea of the region where it will hit, we could notify local authorities and they can clear out that zone, allowing the thing to fall so no one will actually get hit.
Right.
Now, if you happen to be nearby, it's going to explode on impact, make a crater, but that explosion will scatter debris into the area and it'll rain down asteroid particles and Earth particles that have been kicked up. So, but that's less deadly than being where it actually hits and explodes. And by the way, it will explode. And you say, well, how is it going to explode if it doesn't have any bombs? So here's how that works. Okay, this is a very subtle point. It's a high-speed impact, which has a very specific meaning. It's not just that it's going fast.
All right.
Okay, so here's an object moving through space. And you ask, well, how fast is it going?
How fast is it going?
So you get at its speed, it'll hit us at a minimum of 25,000 miles an hour. Okay, that's about 7 miles per second as a minimum. All right, but that's if it just sort of fell to Earth. If it has motion of its own, combined with motion from Earth, then what you really care about is the closing speed. And then that could be upwards of 40,000 miles an hour, okay? Nearly double that, okay? So you have to just sort of watch for those numbers. So here we go. So here's it coming in at very high speeds. Now you can calculate what we call the kinetic energy. You probably heard the term. Mm-hmm. It's a very specific measurement you make. You ask how much mass is there, and how fast is it going? Mm-hmm. Okay, that's all the only two things you need.
That's all you need.
That's all you need. And so
it's a
kinetic energy
cake.
is 1/2 times the mass of the object times its velocity squared. Okay? But the mass times the velocity squared. Oh, by the way, it's not an accident that what's Einstein's most famous equation?
E equals mc squared.
Notice there's a mass,
right,
and c is the speed of light squared.
Right.
But notice it's a mass and a velocity squared.
Gotcha.
It's an energy. So mass and a velocity squares are energy no matter how you slice them. So one way to write down a value of energy is the mass times the velocity of that object squared. That's all. That's what I'm talking about there. It's not an accident that E equals mc squared has that same structure to it. So kinetic energy is 1/2 mv squared. All right. Write down that number. Okay. Mm-hmm. Write it down. Right. Now ask yourself, what's holding the thing together?
Right.
All right. So go down to the molecules, and they're molecules connected to each other inside this solid object. And you can ask, with what energy are these molecules hanging on to each other? Mm-hmm. Okay. So imagine you and I standing next to each other. We just lock elbows. Okay. Right. So we're all just molecules locking elbows. What will it take for two people to pull us apart? That's a certain energy. Right. That'll either release your grip
or rip your arm off.
Or rip your arm off, right? Both of them. You can calculate what those energies are. You can either release the molecule or bust the molecule open. All right.
Right.
Do that for all molecules in the object. That's a total energy. It's called a binding energy of the object. Okay. So now I have a kinetic energy of its motion and a binding energy of the physical object. And you ask yourself, which of these is larger? If the kinetic energy is larger than the binding energy, we'll call it a high-speed collision. And here's what happens. This object is coming in, it slams into Earth with very high kinetic energy. Well, velocity is one of the terms in the kinetic energy equation. Right. After it hits Earth, how fast is it moving?
Minus whatever.
How fast it
it hits Earth, it's moving with velocity. It already hit Earth.
It hit Earth. How fast is it moving?
It should stop.
Give me a velocity.
Right. Minus the
didn't minus that. I'm asking a simple question.
How fast is it moving? The velocity.
What is the velocity after it has hit the Earth?
I don't know.
Yes, you do. It hit Earth.
0.
Thank you. 0.
It's 0.
Okay. So then I ask you, where did all the kinetic energy go? No such thing as a free lunch in this universe. So all that kinetic energy on impact with the Earth, it did several things. One, it makes a crater. It flies things up into space, but it also goes back into the object itself, completely destabilizing everything that's binding it together. Because it's more energy that's holding it together. And so the instant that happens, the thing can't stay together, and so it explodes. Period. That's how you get the explosion. That's why you get the explosion. In fact, that's why every crater you have ever seen on the moon is a good example, but look anywhere in the solar system, is a perfect circle.
Right.
Even if these suckers come in at an angle, you think, oh, it'll make an oval crater. Yes, the uncertainty ellipse is an ellipse, but once it hits, it explodes. And the explosion is what we say is isotropic. It's the force is the same in every direction. It makes a perfectly circular crater. And usually the object can't be found. It'll vaporize 90-something% of the object. If you're going to look for a big rock that's there, you're not going to find it.
Wow.
In fact, they did, that big, Arizona is known for its holes in the ground. Right?
Okay, yeah.
So one of them is a meteor crater, we call it.
Oh, you mean actual celestial caused holes in there. I thought you meant dive bars. I was going to say, yeah, you're absolutely right. It's
No, those are holes in the wall, not holes in the ground.
Oh, that's right. They are.
Yeah, that's right. So with that, when people said, if this is left by a meteor, there ought to be a big meteor down in the middle. So they started excavating. They couldn't find anything. It's before we understood this whole concept of a high-speed impact,
right.
a high-velocity impact, where you basically vaporize the object in an explosion.
It's a cosmic pillow fight where the pillow explodes and there's all the feathers are all, and we're still frolicking.
Well, that's an important analogy, because a high-speed collision has not as much to do with the speed as it does what is the thing made of. Right? So what's holding your pillow together is some stitching around the edge.
Exactly.
If I slam it hard with more energy than that stitching, and it hits you upside the head, the stitching will break and the pillow will break open, because in that moment, the pillow engaged in a high-speed collision.
Yeah. Same thing happens with a sock full of oranges. Don't ask me how I know.
Yeah, I'm not coming over for your next sleepover. What the hell are you doing? All right. So yeah, that's a long answer to that very good question.
No, that was cool, man.
You just evacuate. You can evacuate in 24 hours. That's why we have roads, right? And why everybody has cars. So plus you can evacuate in every direction. Okay, in most places, unless you're like in the Florida Keys or something. Now you got to go just that one direction. By the way, if it falls in the ocean, then you got to watch out for the tsunami. Okay.
Right.
Yeah, it is something to keep in mind. But most of the Earth is ocean, right? And yes, and so you just leave away from the coastline, and most of that which is land is not inhabited. So chances are it's not going to hit a city, even if it had the power to destroy one.
Well, now I can sleep. Okay.
Yeah, there you go.
That's not bad at all.
Give me another one.
Okay, this is Teresa Onoski. She says, how can there be a collision, cosmic or otherwise, without a lawyer being involved?
Oh, so this is a new dimension for lawyer ads, right? It's like,
exactly.
Was
your house destroyed by a meteor?
Yeah, who are you going to sue on that one?
Exactly.
Yeah. So just an interesting point there. The one of the brightest, most devastating recent now 9 years ago was in Chelyabinsk, Russia. There was an air blast of an asteroid 17 meters across. Some of the best footage we have of that coming in are from forward-facing dash cam footage of cars. And so here's an interesting point, and that's, Europe and parts of Asia have these to obtain video of a collision that you might be in, which reduces the need for lawyers. Okay? Often a lawyer's arguing whether something did or didn't happen, or who was at fault, or who was more at fault than they're claiming, and all of this. If you have video, that just cuts through so much of what might otherwise happen in a courtroom. So you can imagine a day where everything, I wouldn't want this because it's an invasion of privacy, but if we had a video of everything, well, okay, that didn't make a difference with in Los Angeles in
It
1991.
did not. I was about to say.
I
was going to say.
Sorry.
You can have all the video you want.
What's that boy's name? I forgot.
That was Rodney King.
Rodney King. Okay, so I take it back. Apparently, video doesn't matter in some cases. Okay, if you're getting your ass whooped by the cops, apparently it doesn't matter. But for everything else, it might matter.
Exactly.
So yeah, it's a testament to the fact that human sensory systems are rife with error. Not only seeing what isn't there, thinking you're not seeing something that is, hearing something that's not, perceiving. So it's such rife with error that science really didn't take off until we were able to replace our senses with machines that would have a reliability that we could only dream of having with our own eyes, ears, nose, mouth, and touch. Chuck, we got to take a quick break, but when we come back, more cosmic queries on cosmic collisions on StarTalk. We're back. StarTalk, cosmic queries. Cosmic collisions is the subject. One of my favorite subjects. In fact, I give a series of public talks around the country at a theater near you, and I give the host a choice of what topics they might want to hear from me, because I have nothing really to sell you other than the universe itself.
And so the ticket.
and so they see the I don't have a product to sell you other than, like I said, the universe.
Joking. I know what you meant.
And so it's one of the subjects is cosmic collisions, and every now and then they pick that, and they're usually in for a treat because it's just a fun topic, and so many things shape the universe by slamming into other things, giving us what we think of as something that's beautiful or spectacular. They're really just something coming upside the head of something else.
And I think we also have a odd fascination with the macabre. And
yes, we do. We do.
People just want to know, like, how are we going to die?
Right,
How's it all end? Like, it's like the same thing you watch NASCAR for the crash.
Oh, yeah.
Not one crash. This was the worst race ever.
All right.
All right, here we go. This is Deb Beach. Deb says, hey, Dr. Tyson, a recent article from the New York Times about research in 2003 astrophysicists working with NASA's orbiting Chandra X-ray Observatory. The article notes that the sound waves were coming from a giant cluster of galaxies in the constellation Perseus caused by explosions from a huge black hole 250 million light years away. They provided a sound clip that was modified so that we could hear the quote-unquote music of the black hole. My question is, how musical noisy is our galaxy? And what other phenomena creates sounds in space?
Here's the thing. I'm not a fan of turning astrophysical data into sound. I get it, and it has some value. I'm just not a fan because of all of the off-ramps that gives a person into thinking the wrong thing about the universe. Okay? So let me just start it out by saying any energy that creates a change of pressure through a medium is creating sound.
That's how your eardrum works.
That's how your eardrum works, okay? There's air, is pressure in the air. It puts pressure on the eardrum. It gets converted to electrical chemical signals that your brain then interprets as sound. Okay, anything. So most things actually make sounds, okay? If you could hold a microphone up to the sun, it is gurgling, and they're like pressure waves inside the sun. Right. Oh my gosh, I mean, gurgling, the sun is actually boiling. All right, it's hot in the middle, less hot at the surface, and anytime you have a heat gradient, if that gradient is strong enough, gradient is a fast change in what it is, then you'll have boiling, such as what would happen on your stove. Right. So, point is, what they did was they found places in the universe where the medium, the intergalactic medium, depending on which research results they're looking at, that there are these pressure waves through it. Now, but they're very low frequency. Very low.
Like
microphone.
Like basso profundo low?
Like Basso If you all never heard Basso Profundo, just Google some YouTube videos of it. It is a hoot.
It's nutty, man.
It's nutty. They go the voice is so low you can almost look at their vocal cords vibrate, you know?
Right. Yeah.
Anyhow, so it is such low frequency that in order to hear it, they had to artificially boost the frequency by 47, 48 octaves.
Well, that's nothing
Octaves.
like what you heard then.
Right. So if you were there, you just wouldn't hear it. The sound would sort of wash over you. You wouldn't even know it was sound.
Right.
So you boost the frequency. Now you can hear it in this narrow range. Well, we have several orders of magnitude, 20 hertz to 20,000 hertz, if I remember correctly. And that's a nice range, but it's small compared to the total possible ranges that are out there. Go ask your dog. Okay.
Yeah.
Okay. All right. So
That's
it's funny, Chuck, you and I grew up at a time when in our biology books, the human body was praised as some kind of pinnacle of evolution.
Exactly.
Yet we still use our dog to sniff out drugs because we can't, right?
Yep.
When dogs can hear frequencies, we can't.
Yep.
Right? People say if a tree fell in the forest and no one was there to hear it, did it make sound? Yeah, because the dogs heard it. Okay?
right. That's what your dog is hearing every time you see him. Just look up like, what? And there's nothing going on. Just nothing.
They heard the tree fall. I like that.
He was like, another tree?
Chuck, I'm gonna tweet that.
Right. He was like, wait, somebody just destroyed my bathroom.
I peed on that tree yesterday.
Exactly. Another perfectly good bathroom just destroyed.
So anyhow, the point is that if you do that and then say these are the sounds of the universe, it's a little misleading because it's not what you would hear. Plus, most of the rest of space is empty, and sound needs a medium through which to transmit. And so not only wouldn't you hear it when it was there, it wouldn't travel to you anyway. So that's why I'm always a little uncomfortable talking about and thinking about sounds in space.
Gotcha.
And by the way, there's a medical condition called synesthesia. I find a fascinating condition where your sensory wiring is crossed. So I think I get it right. There's some people who hear colors, who see sounds.
Okay.
Yeah, so it's fascinating sort of cross wiring of your senses. So what we've also done is we've taken frequencies of light in images, and because the different frequencies, there's, red, orange, yellow, green, blue, violet. Those are different frequencies of light. But we see way more than that with our modern equipment. We see ultraviolet, infrared, X-rays, gamma rays. So I've seen some people take those frequencies and attach a sound to them. And then they have that sound emanating from an image and the combination of sounds from all of the data that's in the picture. So when I first heard that, I said, no, that's wrong. You can't do that. But then I realized I was speaking with Richard Dawkins, who strongly suspects that because bats are mammals and they have basically the same brains we do, a lot of the same processing power, he thinks that bats hear in color. Okay. Because what else would they be doing with the part of their brain that sees color? Why not hand it the audio signals that they're getting from their echolocation? So if a bat can hear color, then I thought to myself, why should I have a problem with us seeing sounds?
Right.
See? Okay. So in that regard, I maybe we're at the beginning of a whole new way to bring data to people. Because if you're sight impaired, for example, you want to hear what the picture looks like. I mean, why not?
That's kind of cool.
It'd be kind of cool. There's surely a whole future in that. If you're hearing impaired or vision impaired, you bring the data into another sense, but you want to do it sort of authentically, right? If there's a separation of frequencies, you map them into a new set of frequencies that are still separated in that new regime. So anyhow, so that's how you get sounds in the universe.
Nice.
And by the way, collisions and things, they all make sounds if you're right where they are, but you wouldn't hear them if you're out in space. That's the only difference. So in that regard, Star Wars would be silent movie.
Right.
Just so you know.
And there goes the box office.
Okay. All right.
God, it was so great. If only they had some kind of sound effects with it, it would have been even so much better. God.
Yeah, we don't like watching silent explosions.
No.
I think that's what that comes down to.
Nah, this is America, baby.
America.
It's America.
We're really good at blowing stuff up, and we're less good at knowing where the pieces go at the end, by the way. That's a whole other conversation. Chuck, we got to take a quick break. When we come back, part 3 of our 3-segment Cosmic Queries about cosmic collisions. Chuck, we're back. You know, I've been giving sort of luxurious answers to those several questions we've had so far.
That's
on
fine.
Cosmic Queries. No, let's do a little bit of lightning round. I want to show people I'm capable of that. Okay?
Yeah, I just say we do another show, a second show. And everybody who didn't get, if you didn't get your question asked, then
We'll
come
just
back.
we'll do it again.
Just keep, we'll do it again. You'll get your
we'll try it.
question. I'll, don't
I'm still
worry.
going to try it. Okay, go.
Okay, we'll try it. Here we go. Zachary Clear. Okay. Zachary says, greetings, Dr. Tyson, Lord Nice. I recently read that upon a recent published work in which researchers suggest that when two progenitor galaxies collided head on, their dark matter and stars would have sailed past each other. The dark matter would not have interacted with the stars, which would not have been able to, too far apart to collide. But as the dark matter and the stars sped up, the gas in the space between the two galaxies and stars would have crashed together, compacted, and slowed down, leaving a trail of matter that formed, dun, 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 a new galaxy. You just described galaxy sex, bro.
Wait, did his question have the sound effects in there too, or did you add those?
No, I
did he go da da da?
Yeah,
Okay,
no,
everything spoken there is accurate. So here's what happens: the galaxy collision is one of the most beautiful balletic things you've ever seen.
Okay.
So first of all, galaxies are mostly empty of stars.
Right.
All right. So if there were just a few bumblebees flying randomly in the continental United States, there's a greater chance that two of them would accidentally bump into each other than for two stars to collide when two galaxies come together in space. That's how empty space is. Okay.
Wow.
So when the two galaxies come, they will basically pass through each other and come out the other side. Okay. The dark matter, whatever that is, we don't know what it is. The dark matter will do the same. Why? Because dark matter not only doesn't interact physically with our matter, it doesn't interact chemically, it doesn't interact with itself. So it would have to interact in order to make a dark matter planet, for example, or a dark matter star. Something has to work such that it can become compactified. Why are you a solid object, Chuck? Because your molecules are sticking to each other in some way that turn you into Chuck. Dark matter, as far as we know, has no ability to stick to us or to stick to itself. So the dark matter passes through. But the gas clouds, they are not going to, you can't pass gas through gas. Okay?
Yeah.
Sorry.
I'm sorry.
Before I trigger a cascade of flatulence jokes from Chuck. Okay. That we can't pass gas through gas. But gas clouds cannot move through other gas clouds without consequence. It's like two hot marshmallows touching each other. They stick.
Right.
You ever done that? Two hot marshmallows?
Absolutely.
It's like contact cement.
Yeah.
So everything else passes through each other. The gas sticks together, and that energy feeds the formation of new stars. And so these filaments of gas that are left over from these collisions, you can basically form an entire family of dwarf galaxies by doing this.
It's
very cool.
Pretty damn amazing.
So these are collisions, and the problem is it takes about 250 million years to fully go through this collision. So we know they happened primarily only because we simulate them on the computers. And I want you to appreciate my people, okay? If you're going to collide two galaxies, every inch the galaxy moves closer to itself the sum of all the gravity vectors operating on every point in space changes.
Right.
So if you're a star, you take 3 steps to the left, everybody else took 3 steps to whatever they're going, and now the total gravity field is different. And so you have to recalculate what's tugging on you and in what direction. And once you go through this exercise, that's when you find this extraordinarily balletic collision. It's like a train wreck, right? The structure, the beautiful structures of the galaxies get completely destroyed and distorted. And it's just beautiful. So if I wanted to see a phenomenon in the universe, I would want front row seats for 250 million years on the collision of galaxies.
Very cool.
Oh, I left something out. So these gas clouds will make their own shards of galaxies, but the system of stars, they will pass through each other, come out the other side, but they still see one another, and then they'll slow down, stop, and then collide again. And this will continue until it settles into a new galaxy that is completely that has lost all of its, there were spiral galaxies, it would completely lost all of its beautiful spiral structure. And it'll become one big giant blob of stars. And if they each had black holes, the black holes will find each other and merge in the middle.
Okay.
Yeah.
All right.
So back up when that's happening.
Yeah, man.
All right, that was not a soundbite answer. So, but keep going.
Okay.
What else
That was fascinating.
All good.
Fascinating. Here we go. Hello, Dr. Tyson, Lord Nice. This has been plaguing me for a couple of years now.
Who is this? Who is it?
Oh, I'm sorry. Yeah, James Weldon. Sorry, James.
Thank you.
Yeah. This has been plaguing me for a couple of years now. Is it possible the Big Bang and the Big Rip are causally connected? I heard from a science YouTuber once that the amount of energy needed to split elementary particles such as quarks is so infinitely great that the very act would mathematically create new elementary particles rather than actually splitting them.
Well, I like that. By the way, the namesake of this format, Cosmic Queries, became a book published by National Geographic a couple of years ago, and there's an entire section on how the universe will end. Ooh. All right. And all of the hypotheses are there, including the Big Rip, which would happen in 22 billion years if, in fact, the acceleration of the universe continues. And then, so here's what's interesting about the universe. Wherever you have a lot of energy, stuff happens.
Okay.
Stuff happens. I'll give you an example. Okay. Do you know what protons and neutrons are made out of?
Sugar and spice and everything nice.
Yes, precisely that, Chuck. No, they're made out of quarks, okay? Right. Now, we've never found an isolated quark. They're always in pairs. Okay, always. Okay? All right, so now, well, why not? Why don't we just get in there and rip them apart? Right. Okay? Well, here's what happens. As you pull them apart, they pull on each other more strongly.
Oh.
As the distance increases.
It's like a finger puzzle.
Okay. or something even, do people have finger puzzles anymore?
No.
Right? Okay, they don't really have, but well, we're just a rubber band does that.
Right, that's true, yeah.
Right? As you pull on it, it's pulling on you more strongly. So this is a force that operates the way a rubber band does, but watch what happens. If you pull on a quark with enough strength, I finally got it, check, I got it, and then it snaps into two. The energy you put in was exactly enough for the snapping rubber band to create another quark. And now you have 2 pairs of quarks instead of 1.
Nice.
Yes. It is like, don't F with me. Okay. Yeah. You see I'm happy here as a pair of quarks.
Yeah.
Okay.
That's some loan shark stuff right there.
That's right. So I like the idea that the energy required to rip the universe, the very fabric of the universe, is sufficiently high that it could create multiple Big Bangs. I haven't researched that enough to know if there's something that would prevent it, but I'm telling you that energy is opportunistic.
Right.
And so I like that possibility.
Yeah, that's kind of cool. It's just
so like it could be that our Big Bang was somebody else's Big Rip.
Somebody's Big Rip.
Yeah, there you go.
Oh man, I don't want everything to come from anything termed the Big Rip. So I don't want that to be. I don't know what else to call it. It is, the universe is ripping. I don't know what else I'm going to do. Okay.
You know? Right. Yeah, but if you check out the book, There's a whole section if you want to know all the ways the world would end.
All right.
Chuck, we spent so much time, Chuck. We don't have time. Oh,
No.
All right, one more. Quick.
All right, here we go.
Real quick.
Dr. Tyson, Lord Nice, when we detected gravitation.
Who is this?
Wait. Who is it? Jason Whiter. Okay. Jason Whiter, okay. Dr. Tyson, Lord Nice, when we detected gravitational waves from the collision of two black holes, what happened to their event horizon?
Oh, very cool.
Whoa, that's a great question.
It is. And in fact, don't we have an explainer on this with our black hole expert in residence?
Jan 11.
Jan 11.
Yes,
I think we do talk about this.
Yes, we do.
I think it was in an explainer, but I'll just tell you right now, and then we got to call it a quits.
Okay.
So what happens is the two event horizons merge to become one larger event horizon surrounding the total mass of the two objects together. That's what happens. Okay. They enter each other's event horizon when this happens. And Jana gives a brilliant explanation for how that happens and why it happens. And so I recommend you do a fast search on that and you'll get there. All right, Chuck, we're going to call it quits there.
That was great, man. And guess what? We still have like 60 questions left.
Okay.
Which is awesome.
All right, we'll do this again. We'll do this again. Cosmic Queries, second edition, the sequel. And we'll just number them up because there's no end of this. And like I said, it's one of my favorite subjects. So Chuck, tweeting at Chuck Nice Comic.
Thank you, sir. Yes.
I never give my social media handles on this, but maybe I'll...
Because you don't need to. If I had 14 million people following me on anything, by the way, I would stop giving it like, hey, guys, stop. Take it easy. Chill out, okay? I need a second. Can I get a second? You know.
All right, I'll do it this one time, okay?
Right.
On Twitter, it's Neil Tyson.
Right.
And on everything else, it's Neil deGrasse Tyson. On Facebook, TikTok even. And the TikTok is an official TikTok of StarTalk, by the way.
Nice.
We have a bunch of us making sure that works out. And I'm in all the content, but we have people, experts, TikTok, people 1/3 my age. That's the definition.
I like
TikTok expert.
It's cool, man. Oh, that's so funny. Yeah. You got a toddler just like, here's your problem. You're not going to be able to get engagement if you keep doing this.
All right. This has been Cosmic Queries, Cosmic Collisions Edition, the first of what will surely be many. Neil deGrasse Tyson here. Keep looking up.